Hello, in this video we're going to be looking at the angle-secant theorem. So the angle-secant theorem states that the angle measure formed by two secants, in this case line AD and line AC, when they intersect outside the circle, this angle measurement, or angle A, is half the distance of the differences of the arcs that are intercepted by it. So in other words, arc DE, so arc DC minus arc EB divided by 2 is equal to angle A, the measurement of angle A. And so in this, what we are going to want to do now is to prove this. So we are going to create a small proof here. So the first thing we are going to do is we have this, and we're going to draw the line BD. So let's do a little slightly different color so we can see what's going on. So we're going to draw line BD. Okay. So draw line BD, which we've done, and now what we're going to do is let's let arc EB be equal to alpha. Okay, so we're going to label this alpha here, and while we're at it, let arc CD equal beta. So we'll call this beta. So we have alpha and beta here. And one thing we know is that the measurement of angle DBC, that is going to be beta divided by 2. So this will be beta divided by 2. And we can state that by what we call the angle inscribed theorem, and there's another video I've done on that. So by angle inscribed theorem. Okay, so because of the angle inscribed theorem, we're going to call that this right here beta over 2. From here, some other things we can do is we want to reference a few other things, but using also the angle inscribed theorem, we can say angle ADB is also equal to alpha divided by 2. Once again, that's through the angle described theorem also that allows us to do that. So this is alpha divided by 2. And something else we know is that the measurement of angle D, so the measurement of angle D plus the measurement of angle A, and I'll scroll back up to refresh your memory. So measurement of angle D and measurement of angle A, so these two angles that are formed in this triangle, they are going to be equal to they will be equal to the measurement of red hair, which will be equal to the measurement of angle D be C, which we already have defined that to be beta over 2. Okay, and we're able to state that, as I said, we're able to state that by the triangle exterior theorem. So now that we have these different measurements, what we can do is we can just do some rewriting and substituting. Measurement of angle D, we had defined that earlier as alpha over 2. Right? So angle D has alpha over 2. And then we have the measurement of angle A is equal to, as we said, beta over 2. Or if we just by simple algebraic rewriting, the measurement of angle A is equal to beta over 2 minus angle alpha minus alpha over 2. And that is what we wanted to prove, right? We could rewrite that if we wanted. Beta minus alpha over 2. And so that is the measurement of angle A, which once again, angle A is this outside angle. So in other words, we took this outside arc, our largest arc, minus our smallest arc, divided by 2, and that gave us this measurement. And so there's our proof for the angle secant theorem.